So next, let's talk about paging. If we go back and look at the food controller, when we return these values, we're not returning the entire collection. We're not returning the entire collection because returning 4,000 or 5,000 items is almost never a good idea. So we implemented this in the food controller by using take. Take is a query method that says only return the next this many items. So in this case, I'm only returning the top 25 items, which is why all of our food started with A in our particular case. What we'd like to do is support paging here, so let's go ahead and start by adding a new parameter called page, and I'm going to make sure that if it isn't supplied that we're using and returning the first page. We're also going to need to know what the page size is, so let's go ahead and create a page size of, let's say, 50. This means in the take, we can just go ahead and say we're always going to return that same page size. But in order to use paging, we're going to also want to use another query parameter called skip. Now the way you do paging may differ based on how your repository is structured and what your underlying data store is. Because a repository is returning iQueryable, we can just use link in order to handle the paging for us. This means that when we want the first page, we want to skip no elements, but in each successive call for a page, we want to skip the number of the page size times the number of pages. So we can simply say page size times page. Because we're going zero based, the zero page times page size is going to be 0 for the first page, so it'll skip 0. And the next time, if we say page 1, we'll skip the first 50 and then take and display the next 50. Let's compile this and see how well this works. Here in our foods, when we refresh it, we're just going to get that first page. It's actually going to return more than we used to because we're returning 50 elements now. But if we add page equals 1, before I enter this, remember that abalone is the first element here, but when I go to page 1, I'm now getting further down the list, alcoholic beverages. Or if I say page 100, I'm getting papaya nectar. And if I say page 1,000, I'm not going to get anything because we end up skipping the entire collection. So if someone asks for a page too large, they're simply not going to get any results. Unfortunately, this doesn't really solve anything because we can support paging and we can tell them through documentation that page is supported, but we're not really giving them a sense of how many pages there are and how many results there are total, which ends up being important in the whole paging story. So let's go back to our code and let's figure out a way to do that. Let's go ahead and copy results down here, and let's call this our base query. And the base query is going to be just the order by. All the other work is going to be when we actually execute the query here. And the reason for this is we want to be able to get some counts. So let's say total count equals base query dot count. This is going to return to us the total number of items that are available to us from this query. The next thing we can do is get total pages, which we can do by calculating the total count divided by the page size. And we'll use math.ceiling to make sure that we get one more page than we actually need, so that the last page is that partial page. Then comes the question of how do you actually return this in a way that is useful to the users. Some people will return this as header values, but in our case, I like to send this as a wrapper around our collection. So we can do this by changing the return type, in this case just to an object, and what we can return is just a new anonymous object that will get serialized into JSON for us. And I will call this results, which will be the array that is the actual results. I'm doing JSON too much. It's equals. And then I'm just going to add total count and total pages equals total pages. And because we're returning this anonymous type, when we look at this, we're now being fed the information that might tell us a bit more about the operation. This is the total number of pages, so I should be able to go to page 150. Remember, our page number is 0 base, so the last page is 150, and see the very bottom of the list. This is way back, is the last entry. If we go to 1, we should get no results. Now that puts us pretty close to something that's useful, but I want to introduce the idea of adding even more helpful information here. And so let's add 2 URLs. In fact, let me reverse the order of those. Let's go ahead and compute those. In this case, we want to go ahead and create new URLs that are going to be able to be accessed immediately by using them to get the previous page and the next page. So before we can create these, let's go ahead and create a helper. We don't actually have a helper as part of the base API controller. We could certainly do that, but it doesn't come up that often, so I'm going to go ahead and just build it by hand and make sure I get the one from HTTP routing, not the one from MVC. And pass in our request, which is of course required. And we're going to use it here to create our pre-virl, which will be helper.link. And the route name is going to be food, because that's the name of our route. And then the values are going to be page, and it'll do the same thing for next. Of course, this needs to be new. Object that represents the collection that contains our page. So we're simply just going to construct some URIs that are based on what those page values are. Of course, that these both don't actually help if the page doesn't exist. So let's go ahead and say if page is greater than 0, use the helper, otherwise just make it an empty string. Same here, if page is less than total pages -1, because again it's 0 based, then we can create a next one, otherwise we'll give it an empty string as well. And if I've done this right, which no promises, we should be able to take these computed URLs, include them in the return, so that the user of our API can see that there's no previous URL, but the next one is page 1. And as we click through, we can see the previous and next page. We could give them a first and last as well if you feel better about that, but this is usually good enough. And this simplifies what a user will have to do with your API to simply walk through that collection. So if they're showing this in a grid or something like that, they have the pieces they need to be able to show the data as the user asks for the next page, the next page, the next page, etc. You could certainly make this fancier by allowing them to include a page size and to throw errors if the page size is too big, those sorts of things. But this should get you on your way to the type of things you're going to want to do. And I think it's certainly fine that in some occasions to return anonymous types as long as they don't represent the actual entities you're producing. We're never going to produce something that looks exactly like this, though we certainly could. We could create something like a paged result that knew the collection of results that was inside of it and then knew how to do all this computation for us. We could centralize that, but this should get you as far as you need to go. One more topic for this module. Let's next talk about RPC style calls.